Hello, my dear students. Again, this is Teacher Mael and welcome to our video tutorial for Quarter 3, Week 2 of your Mathematics 9. In Week 2 modules, we will be focusing on proving theorems on the different kinds of parallelogram, specifically rectangle, rhombus, and square. Now let us define some important terms that will help us in our later discussion. What is a theorem? A theorem is a statement that needs to be proven before being accepted. So that is why we have to prove first the theorem on rectangle, squares, and rhombus in order for us to be used in our later discussion. And we have also this postulate. Postulate is a statement accepted to be true without proof. What are parallel lines? Do you still remember this? Of course, these are lines that are equidistant from each other and will never meet no matter how we extend them. Another term that we have to remember are perpendicular lines. Remember, these are two lines that intersect to form right angles. Like in the figure, you have their line A and line B that intersect to each other. And upon intersecting, they form four right angles. And each angle measures 90 degrees. So as you can see, you have there on the side, this is the symbol for perpendicularity, which says that line A is perpendicular to line B. And let us recall first the definition of a parallelogram. Remember that it is a quadrilateral with two pairs of parallel sides. And we have also special parallelograms because all the properties of a parallelogram are present in these three. These are rhombus, rectangle, and square. To recall, a rectangle is a parallelogram with four right angles. A rhombus is a parallelogram with all four sides congruent. And lastly, we have the square. A square is a rectangle with all four sides congruent. A square is also a rhombus with four right angles. Shall we start from lesson 1 in your modules? We have theorems on rectangle. Theorem number 1. If a parallelogram has a right angle, then it has four right angles and the parallelogram is a rectangle. To prove theorem 1 on rectangle, let us consider the given example. We have here given quadrilateral wins or quadrilateral WINS is a parallelogram with angle W is a right angle. We are going to prove if the remaining three angles, angle I, angle N, and angle S, are right angles. Now we are using here the two-column proof. We have here the column for the statements and the column for the reasons. Now always remember that your statements must be connected to each other until we will reach the final statement that will prove on what is needed to be proven in the problem. So to understand better, let us start with our proving. Statement number 1. WINS is a parallelogram with angle W as right angle. Reason given, because it is already stated in the problem that WINS is a parallelogram and angle W is a right angle. Okay, shall we proceed to statement number 2? Now your statement number 2 must be connected with your statement number 1. So statement number 2, you have there, angle W is equal to 90 degrees. Reason, we have definition of right angles because it is stated in the given that angle W is a right angle, so therefore it measures 90 degrees. Statement number 3, you have their angle W is congruent to angle N and angle I is congruent to angle S. Reason, in a parallelogram, opposite angles are congruent. Now statement number 4. As you can see, we base our statement number 4 from statement number 3. So in number 4, we have here measure of angle W is equal to measure of angle N, and measure of angle I is equal to measure of angle S. Reason, we have their definition of congruent angles. Now, statement number 5, that is also based from statement number 4. Since measure of angle W is equal to measure of angle N, and W measures 90 degrees, so therefore we can say that measure of angle N is equal to 90 degrees also. Reason is by substitution. So we refer our answer or solution from statement number 2 and statement number 4. Statement number 6, we have there, measure of angle W plus measure of angle I is equal to 180 degrees. Reason, we have there, consecutive angles are supplementary. We already know that in a parallelogram, two consecutive angles are supplementary. Statement number 7, 90 degrees plus measure of angle I is equal to 180 degrees. Reason is by substitution. So we base our statement number 7 from statement number 2 and statement number 6. Number 8 statement, 90 degrees is equal to 90 degrees. Reason, we have the reflexive property, which means 90 degrees is equal to itself 90 degrees. Statement number 9, measure of angle I is equal to 90 degrees. Reason, we have their subtraction property of equality. We base our statement number 9 from statement number 7. So in order to find for the value of angle I, we subtracted both sides of the equation by 90 degrees. That is why we are applying there, we apply their subtraction property of equality. Statement number 10. Measure of angle S is equal to 90 degrees. Reason is by substitution. So we base our reason from statement number 4 and number 9. Since it is stated in statement number 4 that angle I is equal to the measure of angle S, so therefore we can say that measure of angle S is also equal to 90 degrees. So that is by substitution. Now statement number 11, angle I, angle N, and angle S are right angles. It can be seen from our statement number 1 until statement number 10. But let us find out what must be our reason. Reason, if the measure of an angle is 90 degrees, then it is a right angle. So in our statement, we have there statement number 5, statement number 9, and statement number 10. It says there that the angle that is being measured there measures 90 degrees. So therefore, they are right angles. Now lastly, we have their statement number 12. Since we proved that angle I, angle N, and angle S are also right angles, so therefore we can say that WINS is a rectangle. Reason, we have their definition of a rectangle. So we already proved theorem 1 on rectangle, that if one angle is right angle, then meaning to say that parallelogram is a rectangle. Theorem number 2. The diagonals of a rectangle are congruent. So we will prove this theorem number 2. So we have here quadrilateral WINS is a rectangle with diagonals WN and SI. So we are going to prove if the two diagonals, diagonal WN and diagonal SI, are really congruent. Again, we are using here the two column proof. We have here the statements and the reason. Statement number 1. WINS is a rectangle with diagonals WN and SI. Reason, we have there given, because it is already stated in the given. Now, let's have statement number 2. Our statement number 2 must be based from statement number 1. Since it is stated in statement number 1 that WINS is a rectangle, so in our statement number 2, we state that side WS is congruent to side IN. Reason, opposite sides of a parallelogram are congruent. Now, statement number 3, we have there angle WSN and angle INS are right angles. Reason, theorem number 1. Okay, statement number 4, angle WSN is congruent to angle INS. Reason, all right angles are congruent. Now, statement number 5, you have there SN is congruent to NS. Reason, we have reflexive property. Statement number 6, it states that triangle WSN is congruent to triangle INS. Reason, we have there SAS congruence postulate, side angle side congruence postulate. Now, where did we base our answer? We base it from our statement. So you have there in statement number 2 that the two sides WS and IN are congruent. And statement number 4, we have also there that angle WSN is congruent to angle INS. And on statement number 5, that side SN is congruent also to side NS. So that is why we have our reason SAS congruence postulate. Now, since we have proven that the two triangles, triangle WSN is congruent to triangle INS, we can say in statement number 7 that diagonal WN is congruent to diagonal IS. Reason, corresponding parts of congruent triangles are congruent, or CPCTC, which means that if the two triangles are congruent, then their corresponding parts are also congruent. Now let's have lesson 2, theorems on rhombus. Theorem number 1 on rhombus. The diagonals of a rhombus are perpendicular. Let us prove that theorem by considering this given example. So we have there the given rhombus rose. We are going to prove if diagonal RS is perpendicular to diagonal OE. When we say perpendicular, they must form right angle upon intersecting each other. So again, we have here the two-column proof. We have the statements and the reason. Okay, number 1 statement, rose is a rhombus. What must be the reason? Of course, it's given. Number 2 statement, segment OS is congruent to segment RO. Reason, definition of a rhombus. Statement number 3, RS and EO bisect each other. Reason, the diagonals of a parallelogram bisect each other. Statement number 4, H is the midpoint of RS. When we say midpoint, it is located at the center. So reason, segment EO bisects segment RS at point H. Statement number 5, segment RH is congruent to segment HS. Reason, you have their definition of midpoint. Statement number 6, segment OH is congruent to segment OH. Reason, that is by reflexive property. Now, for number 7, we have there our statement that triangle RHO is congruent to triangle SHO. Reason, we have there the SSS congruence postulate, side, side, side. So we base our reason from statement number 2 statement number 5, and statement number 6. So let's have statement number 8. Angle RHO is congruent to angle SHO. Reason, we have there corresponding parts of congruent triangles are congruent, or CPCTC. Now statement number 9, we have here angle RHO and angle SHO are right angles. Reason, angle RHO and angle SHO form a linear pair and are congruent. When we say linear pair, these are two adjacent angles that create a line. Or if we're going to add the sum of the two adjacent angles, their sum is 180 degrees. Statement number 10. RS is perpendicular to OE. Perpendicular lines meet to form right angles. So therefore, we already proved that the two diagonals of a rhombus are perpendicular to each other. Theorem 2 on rhombus. Each diagonal of a rhombus bisects opposite angles. Let us consider this given example. So we will prove theorem number 2 on rhombus. Given, you have the rhombus VWXY. So we are going to prove that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, which means that the diagonal of a rhombus bisect opposite angles. So shall we start? We have here the two-column proof, the statements, and the reason. Statement number 1, rhombus VWXY. Reason? Very good, it's given. Now statement number 2, you have there side YV is congruent to side VW, and side WX is congruent to side XY. What should be the reason? Of course, definition of a rhombus. Because a rhombus, all four sides are congruent. Now, statement number 3. You have here, segment WY is congruent to segment YW. Reason? That is by reflexive property. Very good. Now, statement number 4. Triangle YVW is congruent to triangle WXY. What should be the reason? We have here SSS congruence postulate, or side, side, side. We base our answer from statement number 2 and number 3. So since the two triangles are congruent, therefore for our statement number 5, we have there angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. Reason, we have there corresponding parts of congruent triangles are congruent. So therefore, we prove that the diagonals of a rhombus bisect opposite angles. Theorems on square. A square is a closed two-dimensional shape with 4 equal sides. It has 4 right angles as well. A square is a quadrilateral and one of the special parallelograms. We can find the many shapes of squares almost everywhere, like in a game board or chessboard, a wall clock, or in a slice of bread. Now, square is very special because all the properties of a parallelogram plus the properties of a rectangle plus the properties of a rhombus are already in a square. So meaning the square have it all. The definition of a square can also be stated as a square is a quadrilateral that is also a rectangle and a rhombus. A square is a rhombus with 4 right angles. A square is a rhombus with 2 adjacent sides perpendicular. A square is a rectangle with 4 congruent sides. The difference between a square and a rhombus is that all angles of a square are right angles, but the angles of a rhombus did not be right angles. Since we have already proven properties pertaining to rectangle and rhombus, so there will be no further proofs will be prepared for squares. Now let us check if you clearly understand the discussion about quadrilaterals and parallelograms. So what are you going to do is to check the column in the table below that corresponds to the given quadrilaterals. So you have there number 1, you have there the first column for property, and you have there the different quadrilaterals. You have there parallelogram, rectangle, and rhombus. So what we're going to do is to check the column that correspond to the given description or property. So let's start from number 1. All sides are congruent. So we have rhombus and square. Number 2. Opposite sides are parallel. So the 4 quadrilaterals possess this property. So parallelogram, rectangle, rhombus, and square, opposite sides are parallel. Let's have number 3. Opposite sides are congruent. So the 4 quadrilaterals have this property. Property number 4. Opposite angles are congruent. So still they have this property. Statement number 5. Opposite angles are supplementary. So only rectangle and square have this property. Property number 6. Diagonals are congruent. So we have still rectangle and square. Number 7. Diagonals bisect each other. So we have parallelogram, rectangle, rhombus, and square. Number 8. Diagonals bisect opposite angles. So we have only rhombus and square. Number 9. Diagonals are perpendicular to each other. So we only have rhombus and square. And lastly, a diagonal divides a quadrilateral into 2 congruent triangles. It is true to parallelogram, rectangle, rhombus, and square. So I hope these properties are already clear to you. Now let us apply what you have learned in our discussion. So we have here a quadrilateral hope. Hope is a square, and diagonals HP and OE bisect each other at point E. So let us answer the following questions. Can you give the measures of the numbered angles? Like from angle 1, angle 2, angle 3, 4, 5, 6, 7, and 8? Very good. All numbered angles measure 45 degrees since diagonals of a square bisect opposite angles. Now, since each angle there is 90 degrees, so therefore, if we're going to divide 90 degrees, that is equal to 45 degrees. Very good. Question number 2. If HO is equal to 10 centimeters, find the measure of the remaining 3 sides. Of course, the other 3 remaining sides measure 10 centimeters. Why? Because all sides of a square are equal. Question number 3. If diagonal HP measures 15 centimeters, find the measure of the following. Measure of HM, MP, EO, MO, and EM. Of course, HM is only 7.5 centimeters. It is 1/2 of diagonal HP. MP still measures 7.5 centimeters. It is still 1/2 of diagonal HP. EO also measures 15 centimeters because diagonals of a square are congruent. MO is also 7.5 because it is 1/2 of diagonal EO. EM is also 7.5 cm. That is 1/2 of diagonal EO. It's because the two diagonals bisect each other. Let us consider the given rhombus nice. So we have there angle N measures 110 degrees and the two diagonals intersect at point U. Can you give the measure of angle C? Angle C measures 110 degrees because in a rhombus, opposite angles are congruent. What about the measures of angle E and angle I? Both angles measure 70 degrees because angle N and angle I are consecutive angles and they must be supplementary. So what we did here, we have 180 degrees minus 110 is equal to 70 degrees. So angle I measures 70 degrees. And since angle I is opposite to angle E, therefore angle E also measures 70 degrees. What is the measure of angle INC? It measures 55 degrees, which is 1/2 of 110 because diagonals of a rhombus bisect opposite angles. What about the measure of angle IEC? It is 35 degrees. Since it is 1/2 of angle NEC, which measures 70 degrees, so therefore 1/2 of 70 degrees is 35 degrees. If segment NU measures 8 centimeters, how long is segment NC? NC measures 16 degrees because NU is just 1/2 of the diagonal NC. So 8 times 2, that is equal to 16. If diagonal EI measures 24 centimeters, what is the length of segment EU and IU? So EU and measures 12 centimeters because as you can see in the figure, you have there point U is at the midpoint. So it divides diagonal EI into two equal parts, and that is EU and IU. So I hope you learned something from our video tutorial and continue studying. Dahil sa math, ang buhay ay aangat. Thank you for watching!